All right, so today we're learning rational numbers, which, like I just said, it's kind of part one between today and tomorrow. Tomorrow we'll talk about irrational numbers. Okay, so rational numbers. First of all, let's talk about real numbers. There is no such thing as a fake number. All right, and all the numbers in the universe, there's no such thing as an unreal number or a fake number. All irrational and rational numbers are real numbers. So we can think of that like the overarching category here. Now, rational numbers can be written as fractions. They are also terminating or repeating decimals. What does it mean for something to terminate? What does it mean for something to terminate? To destroy it or to stop, okay? So when I think of a terminating decimal, the digits stop. They don't keep on going. A repeating decimal, what do I usually see above a repeating decimal? I see that bar notation above those repeating decimals. So irrational numbers, on the flip side, they never terminate and they never repeat. They go on and on and on with no pattern. All right, those are my two categories. Like I said, today we're going to focus on rational numbers. Okay, so in example 1, all of these numbers can be written as fractions or decimals. All right, so I have 1 4/5. So again, this is why you will not be allowed to use your calculator on Friday. You're not just going to punch in 4 divided by 5 and get your decimal. There's two methods to converting your fraction to a decimal. All right, probably the easiest one and the most consistent one is to do your long division. That way you don't have to figure out, okay, which one can I multiply, which one can I not multiply. I just want you to do division for the fraction. If you happen to have it memorized, that's okay too, because again, you don't have a calculator. All right, we're not worried about the whole number. The whole number is going to be out in front of the decimal. You have to figure out what decimal value does the fraction represent. All right, so this is how you do it. You take the fraction, the top number goes on the inside, the bottom number goes on the outside. Got to do your long division. 5 goes into 4. How many times? 0. Okay, so you put a decimal after the 4 and you add a 0. 5 goes into 40. How many times? 8. So the 0.8 goes down here. 1.8 is my answer. All right, 1.8. The 1 came from the whole number that was already in front of the fraction. Okay, 5 over 33. Okay, so now which number goes inside your division? Which number, guys? The 5 goes inside. The 33 goes outside. Does 33 go into 5? No. So you put your 0 and your decimal goes after the 0. As soon as you start having to add digits, that's where your decimal goes. So now you add a 0. Does 33 go into 50? How many times? Once. So 1 times 33, and now you subtract it. Does 33 go into 17? No, so add a 0 and bring it down. Does 33 go into 170? Yes. Okay, so to approximate this, I round to the leading digit. This is about 30. Pencil died. This is about 30, and this is about 150. 30 goes into 150 how many times? 5. So I'm going to guess 5. Okay? 5 times 3 is 15. Carry my 1. I get 165. Okay? Now I subtract. What's 170 minus 165? 5. Okay? Add another 0 and bring it down. 33 goes into 50 how many times? Once. Okay? Now this is my first indication that I'm going to have a repeating decimal. Because remember, you divided it into 50 the very first time. So, what's 50 minus 33? 17. Now I see a very clear pattern. 33 goes into 175 times. So the 0.15 is repeating. 0.15 is repeating. Okay? So as soon as you get that digit to repeat, that's it. You're done. All right? There's no other option to do this other than to have it memorized or do it by hand. And you can't possibly memorize, guys, all the repeating decimals. Maybe some of them, but not all of them. So -2/9. -2/9. I'm going to go ahead and clear my screen. Does everybody have the second one? Everyone have that one written down? Okay. All right, so for -2/9, which number goes inside the division? 2. Which number goes outside? 9. All right, go ahead and do your long division. As soon as you get that digit to repeat and you find the pattern, you're done. Just write the repeating bar and box it in. All right, 9 goes into 2. How many times? 0. 9 goes into 20. How many times? 2. So 18. Oh, look at there, guys. 9 goes into 20. How many times? 2. Okay. So I know that I'm on the cycle of a repeating decimal. 0.2 repeating. All right. No need to keep going over and over and over again. I'm not going to get out of that cycle of the repeating decimal. Okay. So then it is negative because the original fraction was negative. All right. Any questions? Taylor?
But I thought 0 can't be negative.
Oh, 0. Well, it's 0.2 repeating though. So there are digits after that. So, but no, you can't have a -0. But it's not -0. It's -0.2 repeating. All right. Okay. So now you're going to write a repeating decimal as a fraction, right? The decimal as a fraction or a mixed number. Here's where things get a little different, okay? In that, let's see, writing a repeating decimal as a fraction. There is a process. And I promise you, the first time I explain this, you're going to be like, what in the world did she just do? Okay? But then the second time, you're going to get it a little bit better. And I just want to encourage you. Last year, I had very few students miss this question on the test. Okay? But it's going to look weird at first. Because you cannot simply put 25 over 100 and put it into a fraction. Because 0.25, doesn't that mean 1.252525 forever? Okay? You can't put that into a fraction. So what you have to do instead is you have to get the repeating decimal portion of your number to cancel out. And this is how you do it. You're going to take the original value and you're going to put it equal to 0. Put it equal to x. X equals 1.25 repeating. Okay? So whatever that original number is, you're going to put it equal to x. Now you're going to ask yourself, how many digits in this number repeat? And it's always going to be either 1, 2, or 3. Okay? So how many digits in this number repeat? 2 digits. Okay? So I'm going to multiply this entire equation by 100. 100 is 2 powers of 10. Okay, so I'm going to multiply everything by 100. That means 100 times x, and that means 100 times 1.25. Okay, so 100 times x is 100x. All right, now here's the important part for the next part. If I multiply a decimal by 100, how many place values does it move the decimal? It moves it 2 places. So now I have 100x equals 125.25 repeating. All right, you see, because I moved my decimal, but these digits, they kept going over here, okay? So I'm still bringing the repeating part down. That's not gone yet, okay? All right, so we moved our decimal. Now we subtract the original equation. So now we're going to say minus x equals 1.25. And this is repeating also, okay? So we multiplied by 100. Now we subtract the original equation. All right, here's where we get rid of our repeating decimal. What is 100x minus 1x? 99x equals, what is 125 minus 1? 124. And now watch this. It doesn't matter that these repeating decimals go on and on and on. I'm subtracting it from itself so they cancel. This cancels the repeating decimal. That's what I need. Okay? Now, how do you solve for x? Divide both sides by 99. All right? Now, this number, most of the time, will not be able to be reduced. X equals 124 over 99. Okay? And that's your answer. If you want to change that to a mixed number, you can say 1 and 25 over 99, but you don't have to. Okay? All right. So, like I said, on the first one, it's going to be a little, iffy, okay? On the second one now, all right, we're about to do the same exact thing all over again. Okay, so 0.888. What is the very first thing that I did on the last one, guys? What's the very first thing? Okay, I put it equal to x. X equals 0.8 repeating. There's only one digit that's repeating. All right? So if there's one digit that's repeating, how many powers of 10 is that?
1.
Just one, okay? So I'm going to multiply this by 10. All right? The whole equation by 10. Why? Because there was one digit repeating. So 10 times x is what? 10x. And 10 times 0.8 repeating. So how many times does that bump my decimal? 1. So now I have 8.8 repeating. Does everybody see what I did there? Okay, I bumped my decimal to the right one place, but that didn't get rid of my repeating decimal yet. Okay, all right. Does anybody remember the next step? You can look back. What is going to be my next step? What do I do now? This next step actually eliminates that repeating bar. What do I do? Do you remember what? Subtract the original equation that you just wrote up here. Subtract x equals 0.8 repeating. This is the step that gets rid of the repeating decimal. Okay, because it doesn't matter that 0.8 repeats. I'm subtracting it from itself. What is 10x minus 1x? 9x equals 8. 9x equals 8. All right, now what do I do to both sides? Divide both sides by 9. And x equals 8 over 9. Okay? All right, and that is how you figure it out. That's how you solve it. All right, so changing decimals to fractions and fractions to decimals. Okay? All right, let's practice one more of these. Let's practice at least one more. All right, I want you to try to do this one on your own. All right, negative 4.5 repeating. Okay, so you have 2. I want you to follow those steps and try to do the next one. Okay, did you at least do x equals negative 4.5 repeating?
Yes.
Okay, so good. You got step 1. Did you multiply the entire equation by 10? Okay, so good. You got step 2. 10x equals negative 45.5 repeating. Okay, that's step 2. What is step 3? Minus the original equation. Minus x equals negative 4.5 repeating. Okay, now here's where I probably should have stopped you because you probably did not get this next part. Okay, so you're minusing the original problem. Which one is this? Negative 4.5. That's number 8. Okay. This actually, that's okay. We'll just do it this way. 10x minus x is what? 9x equals, now I subtract, all right, negative 45 minus 4. All right, negative 49. Negative 49. Now divide both sides by 9. All right, and you get x equals, or not x equals, but yeah, that's fine. X equals negative 49 over 9. Okay? All right, and that's it. Okay? All right, so the process is what's important. Okay, let's answer a couple questions and we'll be done. How can you identify if a number is rational or irrational?
When there's a
Repeating decimal, or it terminates, or it's just an integer by itself. Can you give an example of a rational number? What would be a rational number? Give me any example, just tell me.
0.8 repeating.
Okay, 0.8 repeating, yes. Okay, what else? What about an integer? What about negative 3? What about 1/5? What about, this is what we're going to introduce tomorrow, the square root of 100. What's the square root of 100? 10. 10 is a rational number. Give an example of an irrational number. Here's the easiest way to do that. Take the square root of a number that is not a perfect square.
33.
The square root of 33. That's going to be a real messed up number when you take the square root of 33. All right? Or the square root of 5. The square root of any number. Or if you wanted to write it as a decimal, 1.2468. Just make up a bunch of numbers that have no pattern and put a ... behind it. Okay? So irrational numbers never terminate, never repeat. They never have a pattern. All right? So that's going to wrap it up for 9.4. Like I said, it's part 1 to your lesson for tomorrow, which is 9.5.